Assignment 2 of artificial intelligence. Let's start with our EA that's going to determine the probability of inheritance. So let's focus on the main parts. So here we go, given the probability is dictionary with unconditional and what the conditional cases. And we have main function. Here we read our TSP file and have our dictionary of probabilities. And initially all of them are equal to 0. And then here we go through all the person who might have right. And after that, we're gonna consider all subsets with one gen and two gens and put the values into our joint probability, update, and normalize functions that we're gonna consider later. We will load our data, which is our data into the dictionary format. And we have our power set. That's return a list of all possible subsets of our set of people. And our main function, joint probability. Here we have people in these parameters. Initially, joint probability equal to 1. And for each person, we're going to define if person have 2 copies of gen or 1 or 0. Then we determine if we have right. If have, we're going to define mother and father. And if we have parent, we don't have parent. We're going to use probability, unconditional probability in our dictionary and get its value. In other case, we're going to go through the as gen if we have parent. And if parent have 2 copies of gen, our probability going to be 0.99 because we're going to subtract the probability of mutation. If we have only 1 copy, it's going to be 50%. Otherwise, there's slightly chance of mutation. And we're going to determine the probability of mom and dad passing its function. Then, if we have 2 copies of gen, our gen probability will be the multiplication of mom and dad's probability. If we have only 1 copy, it's going to be either one mom or dad. Other case, we don't have heard any of them. And for trait probability, we're going to get its value from our dictionary. Then we're going to, for our overall joint probability, we're going to multiply gen probability into the trait probability. And return. And the last, and here then we have to update our probability dictionary. Initially, as we see, it was equal to 0 all values. And for each person, according to their copies of gen, we're gonna update the value of in our probability dictionary by adding joint probability value. And the same was a trait. Then we're gonna normalize it for probabilities. Why we normalize? Because probability should be between 0 and 1. And to make it into this range, within this range, we're gonna get the total amount of gens, their values, and each value we're gonna divide it into the total amount. And the same for the trait total. It will make sure we go within that range between 0 and 1. We'll see the result here. For example, for Harry, we're gonna define the case we have 2 copies, 1, 0, and the probability of having or not having the trait. So let's go to the next task. Here we load our dataset. For NA values for all delay cases, I fill the null values with 0. So that's the result. And for our KBA, here's the logic simple. If we have bad weather and high traffic and operational issues, the flight's going to be cancelled. In the function inference, we create Boolean values for this one also. And for this case, if bad weather and high traffic, it's going to return 1. And for operational issue, it's also going to return 1. So here we use apply to for x1 means that we're going to apply it for each row. So the predicted equal to 1, we're going to see the result where the probability, where the our flight is predicted to be cancelled. For first order logic, here the difference is that we're gonna work with objects and quantifiers, universal quantifiers. For example, for all destinations here, which is equal to lax and the mass delta to mass is true, we're gonna return 1. Here we apply it as we did before, and here for lax, we have the ones that predicted to be cancelled. In probability and bias theorem, we have the cases for unconditional probability. For unconditional probability, we have to find here the probability flight to be cancelled. And to find it, we get the total number of cancelled flights and divide it into a total number of flights. It's pretty easy, and we can make it using mean function, which implements this logic. And unconditional probability. Here we have our conditions, and here we're gonna find the probability of flight will be cancelled given if bad weather. How we do it? First of all, we find cases, rows where we have bad weather, then use filter. We're gonna filter the cases when we have bad weather and it was cancelled. And after that, remove it into the cases when we have bad weather. And also, mean function implements this case. Beta equal to 0, and the same logic for the high traffic and maintenance issue. In maintenance issues, here we add the 1. And Bayes' theorem's formula for this case. Here we got also the probability of flight will be cancelled given its bad weather. According to this formula, first of all, we have to find the probability of weather. In this case, the difference is that we're going to find it in general world, not in the case of cancelled. We're not gonna use the filter. For here we have then we have find to probability of weather, even if it's cancelled. The file is cancelled. And we're gonna use the same logic as above. We're gonna find the ones that was cancelled and use filter for bad weather and divide it into the cancelled ones, cancelled cases. Then the put values into formula and we get the 0 as we get above. So our AI, here we create the probability of operational issue given it's cancelled, the formula that we all already have used. Then our logic agent. Here we implement our KBA and Bayes theorem to our AI. Here logic is for KBA is the same for operational issue and that weather and high traffic which will return 1. And for Bayes, here initial score is equal to probability of flight will be cancelled in general world. But if, for example, probability of bad weather is higher, then we're gonna get that value. That's why we use max function. And we return score, and our AI is gonna predict. So here we apply the function. If logic different decision is 1, we return 1. Probability is greater or equal to probability placeholder, which is 0.4, which means that our minimum will be 0.4. If it's greater than that, if it is greater than that, flight is gonna be cancelled. It's gonna be any values that you want. So here we apply it, and we have flights that were predicted to be cancelled with AI. Here we have a new scenario with these values. We convert it into the series, and AI predict for this case. In this case, it's predicted to be cancelled or flight. So I think it's